Prepare to experience the strongest radio allowable by law. Secrets will be revealed. Myths dispelled. From the studio gym where excuses never apply, it's Superhuman Radio with your host, Carl Lenore.
Hey, welcome back to another episode of Superhuman Radio. This is a holiday week. We have a really short show schedule, and so we don't want to waste any time. And we're doing really good show today. One specifically for the ladies in the audience and the men in their lives, too. Oh, sorry about that. I didn't mute that. Today, we're going to be talking about menopause and weight loss. This has been a discussion that's been going on for a long time. Does menopause cause greater weight gain or difficulty in losing weight? There are some people who claim it has nothing to do with weight gain and weight loss and energy expenditure, that postmenopausal women are just lazy or they eat too much or all these other ridiculous things. And there have been a lot of us, including myself and Elisa, who look at the science and see something different. Well, today we're going to be talking to Dr. Holly Ingram about a study that was just published over at, let's see here, I have it right here, from the Department of Cellular and Molecular Pharmacology, the School of Medicine at the University of California at San Francisco, that clearly shows that there is a role for estrogen in both energy management as well as the actual ability and desire to move more. Think about that. And we'll be getting into that in just a second. Before we do that, we have to thank our title sponsor, and that's Legendary Foods, making low sugar, zero sugar, decadent pastries. The tasty pastry was designed to replace the Pop-Tart, and it's become so much more. Less than 1 gram of sugar, 20 grams of high quality, high leucine protein. For those of you who are counting net carbs, whether you're on keto or low carb, 4 to 5 net carbs per pastry. But the really the beautiful thing about these tasty pastries is they taste delicious. You will swear you are eating real cake. You'll eat them because they taste great, not because they fit in your dietary guidelines. And best of all, this is the first in my experience doing this show 16 years of a healthy snack that your kids will love more than you. Kids don't like to eat protein bars because they don't taste what like children expect them to taste. They expect them to taste like candy. The tasty pastry tastes like real cake, and you'll have a harder time getting your kids not to eat them all on you. You can now give them to them in the morning for breakfast instead of Captain Crunch or some other random cereal, or send them to school, and they will love them. There's a host of flavors, amazing flavors. Go to shrnetwork.biz/legendary. Use the code SHR10 to save 10% off. And while you're there, look at their seasoned almonds and their flavored nut butters. Once again, zero sugar in their flavored nut butters. You won't believe it, but I'm telling you, it's true. So there you go. And now, without further delay, let me get my overlay up and bring my guest on. Dr. Holly Ingram, welcome to the show. How are you?
Good. Good morning.
Good morning. Good morning.
In California, it's morning time still.
Yes, I know. And thank you for being here, for considering it's early. Why did you do this research? What research preceded this that this needed to be done?
Oh, that's a great question. Well, there's a couple of reasons. One is that I really come from a very molecular and mechanistic type of science. And in looking over the years, looking at how hormones act at a molecular and mechanistic level. And I decided about probably 10 years ago to start working in the brain, especially what we call the neuroendocrine part of the brain, which is the hypothalamus, to figure out how it develops and how hormones might act in this region. And in particular, I was really fascinated by what estrogen might be doing. So, for decades, we've known that estrogen is really important in the brain and it has actions in the brain. So you might have heard of this term that women often use when they go into premature menopause after breast cancer and they have to take drugs. They talk about brain fog. But in fact, nobody really knows what that means. And so I began looking at trying to understand at a very mechanistic level what estrogen might be doing, starting with neurons in the hypothalamus to figure out how they affect energy expenditure. And you gave a wonderful introduction in terms of menopausal women and this weight gain that does occur. And if you look at the data, if you actually just measure the circumference of your waist as we age out from the onset of menopause, there's no doubt that women put on weight and they increase their visceral fat. And like you said, this idea that it's just because everybody's lazy and has no self-control is probably just nonsense. So, I decided to start understanding at a very detailed level what estrogen is doing. And with the idea that if we understood what estrogen is doing, then we could understand how to manipulate pathways and actually circumvent the use of estrogen in hormone replacement therapy. So, which is controversial in itself. The use of hormone replacement therapy is quite controversial in some camps. And so we just wanted to know more about what it was really actually doing in the brain. And that's what has motivated these studies.
From a biological standpoint, there's a really good study on men who are on testosterone replacement therapy. One group was given testosterone replacement therapy. One group was given TRT and an anti-aromatase, an AI.
Uh-huh. Yes.
And then they did this for 16 weeks, and then they washed them out, and then they switched, and they did it for another 16 weeks. So it was clear the results followed the therapy. And the therapy was the men who got testosterone only and had natural aromatization occur lost more body fat and gained more lean mass than the men who interrupted the aromatization process. A significant amount of body fat loss was seen in men who were on testosterone only, which showed that estrogen is lipolytic. Contrary to the belief, people think that, I'm putting on weight because I've got too much estrogen. That's not the case. 99% of the time, it's just become this throwaway statement that doctors will say sometimes, when in fact estrogen is actually lipolytic. And as you point out in the brain, when estrogen is introduced, and when any of the sex hormones are introduced, that is when things like schizophrenia, children develop these psychoses when they go through menopause. Yeah. Women develop them when they go through when they go through puberty. Women go through them when they go through menopause. Women have complete personality changes when they go through menopause. So this idea that these hormones have no role in brain function, you have to be just ignoring all the evidence to say that.
I agree, and I think that it's up to the scientists to actually, give some real facts about what estrogen is doing, and that of course, that extends to what's progesterone doing, what's testosterone doing in the brain, and I'm sure there's going to be more. But you have to understand that for neuroscientists, much of the studies or much of the focus has really been on cognition and the cortex and mapping circuits. And so where I come from in terms of, looking at hormone action, most of the work there has all been done in the periphery, like bones, like breast tissue, like the uterus. And so we know a lot about what hormones are doing in those areas. And we know at a very mechanistic level what they're doing, but actually we just don't know what's going on in the brain. And my lab as well as other labs are really trying to just venture into this system to meld these two worlds of hormone action and neurons in the brain. So I think this is the study that we published in Nature is really a beginning step to getting mechanistic and understanding at a detailed level what estrogen might be doing.
So describe
we're just talking about one little region of the brain, 200 in the mouse brain, 200 neurons in the mouse brain is what we're talking about. 200 neurons.
Right. So to explain how was your study designed? What did you do?
Well, so what we set out to do, we knew that that this one region of the brain, if we activated those neurons artificially, we could get mice to move, and they would really. The videos are great. If you go into the paper in Nature, there's a supplemental data that shows how much those mice are moving. So we already knew that they were moving. We could stimulate those neurons and they would move. And so our goal here was to understand specifically what neurons in this region, when we say that, we're saying, because there's tons of neurons in the brain, right? You have to understand like who they are. And so you need what we call molecular markers, a molecular signature. So that's what we set out to do, to understand what the molecular signature is of these specific neurons that motivate this activity. And when I talk about motivating activity, we're not putting them in, we're not putting them in running wheels. So it would be like a trainer comes to your office and says, okay, Carl, let's get out and move, right? So you're going to move because you have this trainer coming.
Right.
But the question is, you're sitting there in your office. What makes you get up and want to move?
Right.
What motivates you to do this spontaneous movement? And so that's really what we're talking about. These neurons control spontaneous movement. And it's all linked to estrogen because if you, this study was done 100 years ago where they figured out that rats, right before they're going to ovulate, just start moving. And why do they want to move? Well, they want to move so that they can find a mate and for sexual activity. And because ultimately our job is to, survive as a species and to reproduce.
Right.
So this system has been designed so that estrogen comes along and triggers these neurons that then send out neurotransmission or messages to other parts of the brain to then say, let's get up and move. And that's all coordinated with these peaks of estrogen that occur right before ovulation. So I hope that makes sense to you.
No, it does make sense. So we have a working model, a natural working model to go by. We know that when estrogen peaks, it makes these female rodents move.
Exactly.
And we know that it does this purposefully, as you point out, because the only job we have as a species is to further the trajectory of the species. That's it. Buying homes and Teslas and all that, that's nonsense. We have to have babies. That's it. So that's job number one. That's the most important task. So if the body does this because it wants that female to be in the vicinity of a male instead of sitting in her little perch day in and day out, there's a reason for it. And we know that estrogen is the trigger. Because
That's right.
So now we know that. So we have something to go by. Okay.
That's right. And yeah.
So what did you do in your research to leverage this and test this theory?
Well, so we did a couple of things. So then we also discovered that what estrogen is doing is it's triggering the expression of this melanocortin signaling system. Now, you may have heard of the melanocortin, especially melanocortin 4.
I have to break in here. For about 9 years now, I've been talking about the melanocortin system on the show. In fact, I believe strongly that it will come to light that many of the things that we attribute to vitamin D, libido, heart function, brain function, many of the things that we attribute to vitamin D is actually being produced by the melanocortin system. The melanocortin system may be one of the most important hormonal systems in the body for health and longevity. And I've been saying that I use melanotan too. I lay in the sun all the time. I'm a sun worshiper. I'm a huge believer in the melanocortin system. Now, with that, go ahead.
Oh, that's cool. Okay. Well, so the melanocortin 4 system, signaling system, has been really important in human obesity, and from dating back almost 20 years ago, where they found human mutations in this signaling system that lead to really overt and severe obesity, especially in children. And it was known that the effects of these mutations are worse in women and female rodents than they are in males. So that's what got us interested in the system, because we said, well, melanocortin 4 isn't just all about whether you eat or not. It must, in women and females, have to do something with energy expenditure.
Mm-hmm.
And so that turns out to be the case. And this part of the brain that we looked at was completely ignored by the field, because if you looked, you couldn't see it in the male brain, because this is a female specific thing. Estrogen goes up, and then you can actually now see this melanocortin 4 signaling go up. So it had been largely, even though people knew about it, it had been ignored because it wasn't seen in males. And here I'll just say that as scientists, especially those who study metabolic studies, much of the focus really over the last 20 or 30 years has been using male rodents.
Yeah, because of that pesky hormone estrogen makes everything unpredictable.
Exactly. So, instead of saying, we just don't want to deal with that, we're just going to deal with males, we completely missed out on all this amazing information for female rodents that could apply to women's health. And so, that, if you ask me what motivates my studies, that's the number one motivation, is working on issues that really affect women's health. And there are many, many in different systems of the body.
Every pharmaceutical drug today, and I'm saying this unabashedly because I know I'm pretty 99% right. Every pharmaceutical drug today is only tested on male rodents. SSRIs, blood pressure meds, anti-cholesterol meds. They don't test them on female rodents. And so it's almost like, well, the women are going to have to, it's a crapshoot. We'll see if it works for them. Don't worry about it.
Well, I think it's gotten, now wait, to be fair, I think
yes, I know it's getting better. I know it is.
It's getting better. Yeah. And I think that, as more and more people look into males versus females, they see some incredible differences that can really guide them into further studies that may then change the way we view therapies.
And one in particular, I'm sorry for interrupting. And I know people in my audience are going to say, Carl, stop interrupting her. But it needs to be said that the diversity of the microbiome is affected by hormones. If your estrogen levels are higher, you may have more of these bacteriodetes than firmicutes. If your testosterone level, so we know this. We know that oxytocin changes the microbiome. Women tend to have more oxytocin than men until they go through menopause. So this is another part of the puzzle about the metabolism of drugs.
Right. Well, we're actually one of the projects that we are working on is why women have more irritable bowel syndrome and visceral pain. So that's actually another project where we're trying to understand what estrogen is doing in the proximal colon at a very molecular and mechanistic level to sort of shed some new light on this issue. But back to the brain, I guess, what was great is that we were able to show, especially through my collaborator, Jessica Tolkien at Cold Spring Harbor Laboratory Labs, that estrogen actually directly regulates this melanocortin 4 signaling. So it's this really cool system where you have estrogen coming on board to then regulate the melanocortin 4 signaling. And that in itself, changing the melanocortin 4 signaling, can actually change basal activity. So we did that using, and this is probably one of the sort of the cooler applications in the study, is that we used what we call CRISPR-A. And so you've heard of CRISPR, and that means gene editing. It's this incredibly powerful technique where you can go in and manipulate genes in a wild type animal. I think that's really important to say. We're not using any genetically modified mouse. We're just using wild type mice. So we can go in and basically do these CRISPR tweezers where we go into those neurons and we permanently activate the melanocortin 4 signaling. So now we've bypassed estrogen. We don't need estrogen around anymore. And what we found is that 4 months after we went in and did that manipulation by delivering this virus to that area, those female mice moved twice as far in a day as their cohorts, their control cohorts. So imagine you moving 10,000 steps a day on your Apple Watch.
Yeah.
It's like you're moving 20,000. Now, the sort of the awful news on all of this is that the mice did not lose weight. And that's because they ate a little bit more. They ate a little bit more every day. And there's probably other metabolic compensations that has actually been shown in human studies. It's hard just to lose weight by moving.
Right.
But that, as we say in the paper, it's not all about how much you weigh. It's also about how healthy you are. How healthy is your cardiovascular system, all your other systems in your body.
How much lean body mass you're made of. This idea that we are, I'm 185 pounds and I'm not, I'm 230. But if, I'm 185 pounds, you're 185 pounds, we're exactly the same. And I'm 14% body fat and you're 38% body fat. No, we're not exactly the same.
No,
very different.
No. And if we found that actually the density, your bone density in those mice, that went up 10%. So that's pretty good. So
how about lean body mass? Did we see lean body mass, muscle mass?
We didn't go in and measure that specifically. This is something that we could go back and do. We just didn't see a tremendous difference, but we didn't dig in and look at the muscle itself. I'm not really a muscle biologist. At some level we should probably do that, but we did not.
Because estradiol is anabolic. A lot of people don't think this, but ask any cattle farmer. When they give a cow at the last 6 months of life, they'll give a cow Phenoplex, it's called. It's trenbolone acetate, and this will add muscle to the cow in the last 6 months. But when they add estradiol benzoate with it, it adds 3 times the muscle weight to the cow.
I did not know that.
Yeah, so estradiol is anabolic. It is.
Well, I just speaking of cows, especially in the dairy cow industry, they've known forever about this increased movement in ovulation. And I think originally they created these gates in Germany. The German farmers created gates where they would measure the activity. The cow would go through a gate and they would actually get the activity of that cow. And then they knew when to either artificially inseminate the cow or to mount the cow for reproduction. And so this has been known for quite a long time, that this increased activity right before ovulation. And it's been known in rodents. So it's probably true in humans. I mean, it's clear that for athletes, your peak performance is usually in your what we call the follicular phase, as estrogen is increasing before ovulation, versus the luteal phase, when you're right before you're going to have your period. So what we're finding is there's a lot of supporting data to suggest that this is a real system that exists in humans. And that gets to your title, which is what happens when estrogen goes offline, because none of those circuits are going to be engaged. As soon as you get rid of estrogen, you're going to disengage that circuit.
Okay, I want to save that for the other side of the break. I want to ask you this question. So obviously we see activity, spontaneous, self-motivated activity occur at higher rates in the higher estrogen phase. Do we also see any change in metabolic rate? Do we see a change in the number of calories being burned, not just from the more movement, but does insulin sensitivity change? Does anything else change that may make the individual more prone to just using more energy for everything they do? Mitochondrial uncoupling is another one. Anything like that?
So, those are all great questions. And we've done a little bit with that in terms of looking at glucose tolerance and insulin tolerance. And what you have to appreciate is that when we artificially manipulate these neurons, we can really see this increased activity over about 5 hours. And if we try to do it chronically, we can see activity that persists for several days. But eventually, what we're doing sort of poops out. What we call that in the business, we desensitize the neurons. So what you're asking is, could we, it would be great if we had another method where we could just keep these neurons going day in and day out, and to do all of those tests. But we definitely, when we do it chronically for over an 8-day period, we see this tremendous weight loss if we fed these mice a high-fat diet. Mm-hmm. And we see improved cellular adiposity, so your fat cells shrink. Mm-hmm. We see improved glucose tolerance. All the indices of better metabolism really do improve with this motion or movement, physical activity, as you would expect, right? I mean, that's true for humans as well.
But all of these benefits can be attributed more to melanocortin, the melanocortin 4 system, and what estrogen does to it by revving it up. So theoretically, ASU came up and made melanotan 2, which I've used for years on and off. So it sounds to me like, to some degree, the postmenopausal weight gain phenomenon, if a woman says, I don't want to get on estrogen for whatever reason, I mean, there's a greater acceptance for HRT today than there was after the Women's Health Initiative. But there are still women out there who say, no, my doctor says HRT is bad. So maybe intranasal melanotan 2. I actually make my own at home, and I use it pretty regularly. Wow. And I use it as a nootropic because, believe it or not, it stimulates my brain. But maybe it's doing it in the similar way that the estrogen increases the melanocortin 4 system's receptivity. Maybe it's doing it that way.
Well, I mean, they have, so, right. I mean, they originally developed these drugs for tanning, right?
For anti-cancer, to prep the body before you went out in the sun. Yes.
Yes. And so then, one of the bremelanotide, which is a melanocortin 4, but it hits the other melanocortin 4, melanocortin receptors. It's not just melanocortin 4, but it does like melanocortin 4. It was approved in 2019 for hyposexual
libido. Yeah.
In premenopausal women, interestingly, because of course the only way this is going to work, as you say, is you still have to get that receptor out on the surface of the cell, and that's going to be done by estrogen. So, right? So
now I understand why they only approved it for pre. That makes sense.
Oh, right. This is exactly why they only approved it for, well, they didn't, this connection between estrogen and melanocortin 4 was not known at the time, but they only approved it, interestingly, for premenopausal women. So you definitely have to get that receptor there, so it's out there ready to receive signals from this synthetic agonist. So how does that work? There are side effects with that, and it's given by injection. So there, at least 30% of the women that take it have some sort of side effect.
Nausea, mostly nausea. And then who wants to have sex after you're nauseous? It's like, that's why I never understood it. I thought, okay, honey, we're going to have sex now. Oh, I feel like vomiting. Okay, let's do it. Like, how does that work? And by the way, it works intranasally too, because I've actually compounded myself at home.
And so I didn't know if bremelanotide will work nasally. I know that you do an injection. So nevertheless, I think it is pretty interesting that they've come up with this drug for hyposexual desire, is what they call it. And you do wonder, I mean, I actually think, and they don't really know where it acts and how it produces this effect, but I'm just going to bet that it has something to do with the neurons that we discovered.
Because, I bet you're right.
They project. So the other interesting thing is that we found that these neurons, these 200 neurons, project to some really interesting areas of the brain that are involved in arousal and social memory. So we were working on that to understand a bit more on that.
Okay.
But
sorry. We're going to take our first commercial break.
Okay.
When we come back, I want to pick up specifically with your study and get a little deeper into what you learned. And I also want to know if there were any aha moments for you. Did you have something happen and you thought to yourself, I did not expect to see that? So we'll talk about that stuff on the other side of the break, okay?
All right, thanks.
Okay, sit tight. We'll be right back with more Superhuman Radio, and I promise not to keep interrupting like an ADHD child. I promise.
New Mass Pro Synthogen X2 just upped its own legendary game. To distance itself even further from the rest of the pack, Synthogen X2 now has double the key active ingredients. If you've ever wondered what steroid-like recovery feels like, Synthogen X2 delivers. See why others compare it favorably to powerful bodybuilding drugs at synthogen.com. Mass Pro Synthogen. When you train with it, you'll gain with it.
Have you been struggling to achieve results in the gym? Trouble sleeping through the night? Overwhelmed with stress or anxiety? Look no further than Infiniwell supplements. They have designed products to address specific needs like muscle growth, hormone balance, sleep, and anxiety from the first use. Infiniwell helps you live well. Go to shrnetwork.biz/bewell. That's BEWELL and use code SHR20 and start living well today. day. Microbes make up your immune system. That's why I'm really excited about P3OM. P3OM is a patented probiotic that might be the most effective probiotic ever developed. P3OM fights bad bacteria and strengthens immunity, basically a germ-fighting superhero. But it also helps digestion, speeds up metabolism, and increases energy throughout the day. That's way more than I thought a probiotic could do. And just when I thought P3OM couldn't get any more powerful, I watched a video that you can find at shrnetwork.biz/P3-OM of this probiotic literally breaking down a piece of steak. After I saw that, I was all in. Here's some more awesome news. You can get 10% off P3OM right now by going to shrnetwork.biz/P3-OM and by using the coupon code SHR10. And if you order it and it's not everything that you thought it would be, they will give you 100% of your money back, no questions asked. So if you want to protect yourself from whatever bug is floating around this year and take your digestion to a new level, visit shrnetwork.biz/P3-OM and use the code SHR10 to save 10% off today. Being superhuman means being conscientious about the choices we make. White Oak Pastures is superhuman when it comes to raising livestock. They're committed to animal welfare, land regeneration, and rural revival. They responsibly manage the entire process from the pasture to your doorstep. High quality, pasture raised, great tasting meat from a farm you can trust. Full nose to tail selections. They even have options for your pet. Go to shrnetwork.biz/white oak and use the code superhuman to save 10% off your entire first order. Remember those rectangular toaster pastries you used to love when you were a kid? Well, Legendary Foods has just made them better. The new cake style tasty pastry is like nothing you've ever had before. With 20 grams of high quality protein and less than 1 gram of sugar, you'll feel like you're cheating, but you're not. Go to shrnetwork.biz/legendary and use the code SHR10 to save 10% off your purchase of tasty pastries. Now available in cookies and cream, red velvet cake, birthday cake, blueberry, strawberry, brown sugar cinnamon, and hot fudge sundae. Go to shrnetwork.biz/legendary and use code SHR10 today.
You're listening to the Superhuman Channel. Don't hate us because we feel good.
Welcome back. We're talking with Dr. Holly Ingram. We're talking about how estrogen affects body weight in postmenopausal women. And this is very fascinating. So let's talk more about your research. Earlier, you first of all, are you pro HRT for women? No. I want to ask you this question because I have some questions.
Here is what I do feel. I feel that this decision that was made after the nurses study, the famous nurses study, that has now been relooked at and people have found flaws with its design, etc., changed the way medicine was practiced for, millions of women overnight. So to me, that was I look back at it now as an older woman and say, how did this happen? How did one study overnight change the way medicine was practiced? Largely, for women that were seeking treatment from men. Okay, because remember, that was, back in 2000, there are not as many women doctors as there are men doctors, and especially in research. So I really questioned, when you really dig into that study and you look at the increase, what they called the increase in breast cancer, it was very, very small. And then you go back and you look a little bit more, the study wasn't done with a huge number of women. Many of those women were overweight and many of them smoked. So, in today's world, I don't think that study would cut mustard in terms of making huge policy decisions that the medical community made. And they just said overnight, forget it. You guys want hormones, you're not going to get it. Even though, you can think better with it, you feel better with it, your metabolism is better with it, your bones are stronger. No, you're not going to have it. And, that really irritated me. That, as a woman, that irritates me. And I think that is also what motivated me to start digging in and understanding what estrogen is doing, because we have to have that knowledge in order to make good decisions at a public health policy point of view. So is hormone replacement therapy beneficial? I think it probably is. Maybe for my mother's generation, where every woman was given hormone replacement therapy and given quite a bit of it, maybe that wasn't such a good idea. But yeah.
And also the type, they were given methylated drugs that are known to cause hepatic stress, thrombotic index goes up, and all these things because of the preparation, not because of the hormone. And number two, they were largely given equine estrogens and progesterone. Horse estrogens and progesterones are not human estrogens and progesterones.
Well, right. So they were given, I know they were given, I talked to my mom, she was given lots of estrogen, and my grandmother as well. So, come on, let's see, we're at 20 years later. We have more tools at our disposal for hormone replacement therapy. And I do think that we should really be looking at this, because, okay, so here's the other fact that women really need to think about, is that 200 years ago, what was our life expectancy?
60 something?
Well, 200 years ago, it was even lower than that. So, I mean, obviously some women would live a long time, but the average life expectancy was not going to exceed when you go into menopause.
Mm-hmm.
So this wasn't such an issue 200, 500 years ago, right? But now we're all living a lot longer. Mm-hmm. So the question is, if the average woman goes into menopause, perimenopausal, about 47, then, do the math. We're living at least 3 decades without estrogen on board.
Right.
And we're asking our bodies to age really well without this very important hormone. And it is true that, while women live longer, they also suffer from aging diseases more than men.
Mm-hmm.
So if we can, take the power of estrogen and understand what it does, we can either use it in a good way that's not going to be reckless, or we can find out new pathways that might do exactly the same thing. So as far as hormone replacement therapy, I've had scientists come up to me who are breast cancer survivors. So for a breast cancer survivor, they go into premature menopause earlier and are given these anti-estrogen therapies, like aromatase inhibitors, are things like tamoxifen, and they really can suffer tremendously.
Oh, terrible.
And so I've had one scientist say, I just couldn't deal with it. Even though I'm a breast cancer survivor, I could not think. And as a scientist, I need to be able to think. And therefore, I went to my OBGYN and said, I don't care. I have to have some estrogen on board so that I can function as a scientist and be fulfilled in my life. So that's how powerful the effects of estrogen are.
I know. I actually put myself through menopause at a period of my life. I was using performance enhancing drugs, and I was taking very large doses of aromatase inhibitors with them. And then I took a very powerful aromatase inhibitor, even more powerful than anything prescribed today. It was called ADT. And it was a suicide inhibitor that effectively reduced your estrogen to zero, your estradiol to zero. I lost my libido.
You don't start with much.
What's that?
You're not starting with much compared to what we're using.
Exactly. Well, but I was using very high doses of aromatizing androgens. And so I was trying to suppress them, because back then in my life, I believed that estrogen was evil in men.
Okay.
And so I ended up with insomnia, subjective tremor. I would break out in sweats, which women call hot flashes. I had severe anxiety. And every time I would search on the internet for my symptoms, I would end up at this website called, it was a women's menopause website.
Yeah.
And I'd be reading these posts and I think, my God, this is what I have. And that's when I really started to sympathize with women going through menopause, because it literally derailed my life for about 2 years.
Mm-hmm.
It was horrible.
Yeah.
Until I stopped using those drugs, and it took a while for my body to kind of bounce back. And I was lucky enough that I was young enough to bounce back. So I know what it feels like. And I was going to an andrologist, and he said, "No, you're crazy." I say, "Feel me. Don't you feel my hand shaking?" And he says, "No." But inside me, I felt like there was a vibrator going off. It was horrible. It was horrible. So with that being said, do you think there's a place for maybe the design of a new selective estrogen receptor modulator to help women who don't want to be on HRT but want to move more and not gain weight?
Yeah, that's really a great question. And I know that the drug companies, pharma, has been, looking into making new selective estrogen modulators for breast cancer that don't get into the brain. So that's their goal. And then they have some that do get into the brain that we're going to actually try to look at. I mean, the question is that if you, so what you would have to have is something that selectively hits neurons, gets into the brain, hits those neurons, and gives you the benefit of having estrogen on board in your brain, but maybe doesn't increase your risk for breast cancer or uterine cancer. So that's a tall order, I guess, in my mind, to come up with. But my colleagues in the pharmaceutical industry and in Pharm Chem at UCSF are really brilliant, and they continue to make progress in terms of drug, specialized drug delivery. So just like this CRISPR method, you wouldn't have imagined this 15 years ago, and now it's reality, at least in the laboratory setting, and who knows if it'll be ever used in humans. I mean, maybe that's 20 or 30 years out from now.
Right,
So
right.
science continues to progress because as scientists, we always want to push the envelope on what we can do. So that's why we continue to need funding from the National Institute of Health, which funds most of us. So, I would love to think that there would be something selective that would help our brain. But remember, we also want to help our bones and maybe our cardiovascular system. So it does become, it is a tall order, right? It is a very tall order.
And estrogen does it. And I'm a big fan of HRT for men and for women. I think doing it the right way, with the right physician, can actually be life-changing. It was life-changing for me. In 2007, when I got on testosterone, I thought to myself, oh my God, like somebody turned the lights back on in my life.
Well, the dirty, dark secret, when our article came out and people saw the article that Gretchen Reynolds wrote in the New York Times, I had people writing to me saying that all the OBGYNs that they know are on HRT, but they don't, they're hesitant to just massively give this to all women. And so, with more research, we will come up with the right solution. And I just felt that, that study in 2000, why was one study allowed to change our public health policy overnight? To me, that was, I don't know, that it just shouldn't have ever been allowed to happen.
Medical science is littered with those types of things. And
Probably,
we can sit here, but you know what? That's why doctors practice medicine, because it changes. But being a doctor who's willing to accept change, that's That's something that's different. You have to be forward. We have some questions from the.
Okay.
So the first one comes from A_G, and he is watching, or she is watching, I'm sorry, on YouTube. Does caffeine trigger these moving neurons? I drink coffee every morning, so I feel like moving.
That's a great question. We do not know. We have not looked at what caffeine might be doing to these neurons, but that's a wonderful question that maybe we could look at in a little bit more detail. Remember that for all of our studies, these aren't studies that you can just do in a petri dish. We have to do this in living animals. So it takes time, especially during when we had this COVID shutdown. It was really devastating for our trainees and for our research program. But hopefully we're back up and running, and maybe I'll think about looking into that. That's a great question.
Also from the same poster, A_G. Carl, have you ever experienced anger when using Melanocortin 2? About 15 minutes after I take it, I have a brief fit of anger. Melanocortin 2 causes a rapid increase in dopamine. One of the reasons I use it intranasally is because I wanted to get to my brain first. And dopamine, a rise in dopamine can actually cause a drop in blood sugar. And a rapid drop in blood sugar causes panic. And some people exhibit their panic by feeling angry. We've all talked about when we were dieting and we're hangry because we're hungry and we're angry.
Right.
Blood sugar's going all over the place. So I would be willing to bet that it's from that. And that means that if you even took a lifesaver and sucked on it before you took your shot, you'd probably not feel that anger. That's my guess, my uneducated.
I see. Well, it is true, those same neurons in females that we discovered, there's a similar cohort of neurons that exist in males, and those estrogen-sensitive neurons in males are really important for aggressive behaviors.
Mm-hmm.
So what we haven't gone in and done is done those types of behavioral studies with what we wanted to basically focus in on females and this connection with estrogen. So in males, we do know that those neurons control aggressive behaviors.
Mm-hmm.
Where melana and basically we know that those neurons also have the ability to express the melanocortin 4 receptor. So whether those melana, I don't know, melanotan 2.
Melanocortin 2, MT2, we just call it on the show.
Oh, MT2, okay. And that's a little different than bremelanotide.
Right. But bremelanotide is a small domain of the melanocortin 2.
Okay.
Yeah.
All right. So we've used MT2 in the lab. I don't know if it's exactly the same thing as what you guys are calling melanotan 2, but it definitely hits those neurons, and I'm sure it hits those neurons in males. But again, you have to have that melanocortin 4 receptor being expressed in order to get activity.
Craig Hollander points out to my assertion that estrogen is anabolic. He says the existing data suggests that acute treatment with estrogen does not improve basal muscle protein synthesis. However, estrogen increases the anabolic response to exercise, and this may result in the increase in muscle mass reported in long-term studies. I have the smartest audience in the world.
Wow. You guys are in an area that is fascinating, one that I don't think about very often, which is this effect on muscle. Because I'm really focused on what it's doing in the brain, but this is fascinating.
Yeah, and there's no one in my audience that couldn't sit back here and do this job. In fact, this is my 16th year, so I think I may be shopping for a replacement in a year or two. So Craig Hollander may get an email to fly in and do the show from here for a while. Paula Mariani, who is a longtime listener, said, "Oh wow, sorry, I'm too busy right now to listen live. I do need to listen to this later." Yes, you do. Cola Quench, also on YouTube, says, slightly off topic, but when I took Melanocortin 2, I felt great, but lots of moles appeared suddenly. Is this a cause of concern? No. Melanocortin 2 stimulates all melanin in the body, and everything gets darker. That's it.
Right.
That's all it is. I
So
love this stuff.
I'm going to tell you that I'm a Ph.D., not an M.D., so I will give no clinical advice on
Right.
this show.
Okay. Here's a question again from YouTube, A_G. I got the moles too. They were more like really dark black spots, not
Yeah.
raised like moles. I was able to remove most of them with a cauterizer. Why remove them? Leave them alone. They're part of you. And then lastly, Colaquench says, interesting, since they are still there, I may try cauterizing. I have them from using Melanocorton 2 for years. But the truth is they get dark when I lay in the sun too. So I'm not worried about them. All right, we're going to take our last commercial break. When we come back, a couple more questions about the research itself, and we will wrap up the show. Stay tuned. Don't forget, share today's show. You never know who you're going to help by sharing a show. And it just takes a click. It just takes a click. Okay? Sit tight. Redcon One's new BAR bar is the ultimate soft-baked protein-packed snack bar, powered by peanut butter. Perfect for while on the go to help curb hunger or sneaky sweet tooth cravings. With 20 grams of protein, use as a meal replacement bar or when you're in need of a high-protein snack. Eat a Redcon One bar as a midday snack or for fuel before an intense training session. Go to shrnetwork.biz/Redcon1 and use the code SHR25 and save 25% off these delicious bars today. If you've listened to Superhuman Radio for any length of time, you know I'm a big proponent of peptides. One of my favorites is GHK-Cu, the blue copper peptide. It has the ability to repair and regenerate more youthful expression of skin cells, reversing the signs of aging. Restora Cell's Stem Cell Awakening Serum, along with their other products, contains potent formulations of blue copper peptides and only the highest quality organic ingredients. Superhuman Radio listeners can now save 25% site-wide. Go to shrnetwork.biz/blue and use the code SHR25. Remodel your skin today.
Dogs should be powered by fat and protein, not carbs. That's why Visionary Pet makes low-carb, ketogenic dog food for dogs of all breeds and life stages. From kibble to freeze-dried and even low-carb treats, all Visionary Pet recipes are very low-carb, ketogenic, and made with 100% real meat protein. Shop now and use code SHR for 20% off your first order today. Your dog deserves the lifelong benefits of optimal nutrition. Make the switch to Visionary and see why smart dogs eat low carb.
I would easily say that I am the hugest proponent you will ever meet to doing anything that will improve the quality of my sleep. And that's because sleep is linked to just about every metabolic disorder we see in our population today. One of the easiest things you can do to improve the quality of your sleep is to get a pillow that can be shaped into the exact form factor that allows you to get your best night's sleep. And that is MyPillow. I've been sleeping with MyPillow for a few years now, and I can tell you that when I have to travel and stay in hotels, I don't get a good night's sleep because I don't have MyPillow with me. Right now, you can save up to 60% off of everything offered to improve the quality of your sleep at shrnetwork.biz/MyPillow when you use the code SHR. Or you can call toll-free 800-889-4938. And remember to use code SHR to save up to 60% off of everything at their website. Every day, there's a new wellness trend. Eat that, do this, avoid those. How do you know where to start or who to trust? Inside Tracker helps you cut through the noise by analyzing your blood, your DNA, your lifestyle, and your fitness tracker to provide you with a science-backed trackable action plan on how to live, age, and perform better. Personalized one-size-fits-one recommendations to help you optimize you. For a limited time, Inside Tracker is offering Superhuman Radio listeners 25% off the entire store. Go to shrnetwork.biz/inside tracker, INSIDETRACKER, to save 25% off. Change begins on the inside.
Move over, superheroes. This is the Superhuman Channel.
Welcome back. So, Dr. Ingram, was there anything that surprised you in this research? I mean, aside from the fact that the endpoints in and of themselves were astonishing, did anything happen and present itself that you didn't see coming?
Oh, I'm trying to think about that. I think that I guess I was surprised that melanocortin 4 was involved. I guess I would not have predicted that, especially in that area of the brain. So that was a surprise. And I was also, when we tried this CRISPR activation experiment, I was just blown away by the results because it was so clear that we had this long-term effect on physical activity. And that was just a great moment when we got those results, because then you really know that you have something, because you're just manipulating the levels of one gene, and you're seeing this behavioral output. So for those researchers in neuroscience, or people that think about how genes control behavior, this was a great moment to see just manipulating this one gene would lead to this behavior. Now, I mean, all these other neuroscientists think about cognitive behavior or social behaviors, but this is just a very important intrinsic behavior that is one of the most important things for our longevity, being able to get up and move. I mean, just think about that. If you cannot move, your longevity just plummets. And exercise, or just getting up and moving, is probably going to be the most important ingredient for longevity that we can find. Right now in the Bay Area, there are all these huge startup companies, startup institutes funded by these very rich billionaire tech people. And their whole goal, there's at least 4 or 5 of them, is to figure out how to think about aging, how to make aging better. Well, in fact, I think we sort of have one of the answers, which is to be able to move
I agree.
and continue moving. So how do you motivate people who just are sedentary? How do you get them to move? And what makes some people want to move, like my dad, and he just was always moving and was healthy till 96, versus some other people in the family that gained lots of weight and became more and more sedentary. So to me, this is one of the biggest puzzles that we need to solve in the brain, is what is the motivation for movement, and how do we get more of that? Because we have a problem in this country with exercise. I mean, the people on your show probably exercise a lot, but there's tons of people out there that not only do they eat very unhealthy foods, but the main thing is that they don't move.
Yes. Yes.
So,
Yes. We had a real opportunity during this pandemic to change the message. Like, okay, vaccine is good, these things are good, but by the way, there will be future pandemics. Maybe it's time for you to get healthy. And
yeah.
by saying healthy, I don't mean shopping at Whole Foods. I mean getting up and moving, getting up and exercising, getting up whenever you can and playing with your kids. Bill Bergman says get a dog. The dog will get you moving and help you burn lots of calories. Regardless of there's a lot of truth in that, right? Having a reason to move sometimes. But here's a more important question. My executive producer, Elisa Profuma, writes this. What are your thoughts about postmenopausal putting on weight? Is it simply a calories in, calories out formula? Because that's what a lot of people say. Oh,
yeah.
You just need to move more and eat less, and it's just calories in, calories out. Is it that simple when hormones are at play?
Yeah, I don't think it's that simple. And I think that one of the things that happens in postmenopausal women, and there's really good data on this for humans, is that our distribution of fat changes. It changes from subcutaneous to visceral fat. And anytime you start accumulating visceral fat, all these other metabolic impairments come along with it. Diabetes, type 2 diabetes, fatty liver disease. They don't really understand why that occurs, but it's really clear that postmenopausal women redistribute their fat. And remember that, evolutionarily speaking, women can survive famines much better. And in part, it's really because of where we store our fat, so that we can we can extract it when we need it for offspring. So this is in our reproductive years, the storage of fat is quite different than during postmenopausal times. Do we understand that? We don't understand that yet. So I don't think it's this simple matter of, women are eating more calories, they're moving less. I mean, I do think these hormones are having powerful effects throughout the body in terms of our metabolism and our brain. So we just have to get down and dirty and understand these details at a mechanistic level.
And let's not forget the research that was done on men that shows that estradiol is lipolytic. It helps to burn fat. And if you're in the ditches with estrogen, you don't have that leverage on fat. It's just the way it is.
I'm gonna have to go in and look at those studies because I'm not as familiar with that. But that's quite interesting.
I'll do my best over this holiday to find it and send it to you.
Okay, that'd be great.
I have one last question before you go. So you actually opened my eyes to something. So for years, I've asked myself, like, why doctors, when they put a woman on HRT, it's almost like arbitrarily they have this zone, right? Luteal phase, follicular phase, ovulating phase, and they arbitrarily put progesterone, testosterone, estradiol in, like, as long as they're in this range, but they never synchronize them. They never say, okay, I'm going to put this woman into this phase, so I'm going to have progesterone in that phase, estrogen in that phase, and testosterone in that phase. If you're in any of the ranges, you're good. And really, it sounds to me like forward-leaning physicians should be looking at getting all three of those hormones into the follicular phase, so the woman is more active. She's going to burn more calories. She's going to be happier. She's going to be energized.
Mm-hmm.
What do you think about? Because they don't do that. They don't shoot for a target.
No, they don't. I mean, they just, it's a trial and error, and they use different formulations. And I think they always want to balance progesterone and estrogen when they do hormone replacement therapy, because people have looked at estrogen only versus the combo pack. And I think they feel that the combination is better in terms of maybe preventing development of breast cancer and uterine cancer.
Right.
So I think there again, that's a great question, because the one size fits all is probably not right.
Well, Dr. Ingram, it's no size fits all. If your estrogen is in the follicular phase, your progesterone is in the luteal phase, your testosterone is in the ovulatory phase, your body is confused. It's like, what am I supposed to be doing right now?
Well, remember that all your testosterone gets for women is going to get converted to estrogen. So, you can sort of remove testosterone and really just think about estrogen. So it's really just estrogen and progesterone that we have to think about. But in terms of, finding the right dose that's going to eliminate the symptoms and make you feel like you want to get up and move, is something that we need to pay attention to. And, in terms of getting hormone replacement therapy, some women can go in and get it. Other women go in and their doctors say no, or it becomes very expensive and their insurance companies won't cover it.
I know.
So that, to me, I don't know, that we really do have to relook at this in a very detailed and thoughtful way. So that's what I'm pushing for in terms of this research, is to take a real relook at HRT for women.
Now, I have to ask you one other question. Is that a Nobel Prize certificate on the wall behind you?
Oh, that's one of my husband's many certificates. He actually just won the Nobel Prize for Physiology or Medicine in this October 2021. So these are all of his prizes.
And his
Mine
name
are
is,
all hanging over on this wall, but I don't have as many as he does.
and his name is.
David Julius, and he's from Brooklyn, Brighton Beach.
Oh yeah, good.
And,
See, that's why it's from all us guys from Brooklyn were sharp.
I know. The minute you spoke, I said, "Whoa, this is my husband." And he went to Lincoln High School, and he attributes all of his wonderful motivation and science to his physics high school teacher in a public school. And we've all been in public schools. Both he and I have attended public universities, public schools, and I really want to give a shout out for the public school system, especially in California, where we have a fantastic University of California system.
Yeah. Well, it's been fascinating and wonderful to have you with us today. I hope you enjoyed it. Will you come back when you have new research?
Absolutely.
Okay. Well, you have a wonderful holiday, and we'll talk again soon. Okay.
Thank you.
And that's it for today. This is the only show I'm producing this week because I'm getting ready for the holiday. We have guests coming in, and we have lots of entertaining to do. But please share the show. You never know who you're going to help. It's an important show. A lot of women are confused about HRT. I'm a fan of HRT, and I'm a fan of testosterone for women too, because while it does convert to estrogen, estradiol, it in and of itself in its native state produces some wonderful effects for women. And that's it for today. We'll see you next week with more Superhuman Radio. Have a wonderful holiday. And remember, the most important thing in the world is to spend time with family, because none of us are going to be here forever. Try as we will, I don't think it'll happen. Okay, take care.